All right, in this video, we're going to be reviewing 8-9. This is the last lesson in Chapter 8, all about perfect squares. So we're going to start with perfect square trinomials. And before I kind of look at the example on the worksheet, I wanted to go over it with you kind of in my own way. So basically, a perfect square trinomial is one in the form this guy or this guy. Now, I know when we look at a formula and we see A's and B's and blah, 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 okay, like my mind goes swimming, right? I have no idea what to do. I need a real example. So we're going to do real examples here in a second. But what I wanted to show you is when you've got what's called a perfect square trinomial, it comes from taking a binomial and multiplying it by the exact same binomial, right? So in our perfect square trinomial, the first term is going to be a perfect square, the last term is going to be a perfect square, and the middle term is going to be the square root of the first term times the square root of the last term times 2. Okay, I know that's a lot. When there's a plus sign here, it means there's a plus sign in my two binomials, right? And this is the same thing as this. So we started with this, and when we multiply it out, we get this guy. If we start with this guy and we factor it, we get this, right? Over here, if there is its exact same trinomial form, but the first symbol is a minus sign. The second symbol is always going to be a plus, but the first symbol is going to change. If it's a plus sign, that means there's a plus sign in my binomials. If there's a minus sign, that means there's a minus sign in my two binomials. But they're still exactly the same. Okay, so it's going to look like this. Remember when we had the difference of squares? That was actually a trinomial where the middle term cancels out, right? And so we end up with a squared minus b squared. And we got that trinomial, I guess, that answer from multiplying two binomials that look exactly the same, but one has a plus and one has a minus. So we've dealt already with a plus and a minus. Now we're dealing with two pluses and two minuses. Okay, so I hope that kind of works. All right, so now I'm gonna give you an actual example. We're gonna start with this and we're gonna multiply it out to get the trinomial, okay? And then once we can see how we get the trinomial, hopefully it'll make more sense when you factor it and go backwards. All right, so this is the same as x plus 3 times x plus 3, right? So we can just distribute like we normally do. So I'm gonna multiply this first term here by both terms in the second parentheses. So x times x times positive 3, so that's plus x times 3. And then I'm going to multiply the second term by each term in the second binomial. So 3 times x, that's positive 3 times x, and 3 times 3, that's positive 3 times 3. Okay, so then when we simplify this, I get x squared plus x times 3 is 3x plus 3 times x is 3x plus 9. And then we notice here in the middle, we've got two of these, right? So when we combine them, I get x squared plus 6x plus 9. Okay, so this is my answer after I multiplied out, oops, I always forget it's going to smear the pen, sorry about that. After I multiply out a binomial that looks like this times itself, right? So the first term squared, the second term squared, and the middle is just the first times the second times 2. That's it, right? That's how we got this. So let's do an example factoring backwards. So I can give you, I got to come up with it. Let's do m squared plus 8m plus 16. Okay, so to know if this is a perfect square trinomial, it has to fit a few criteria. Number one, the first term has to be a perfect square. M squared is a perfect square. We just multiplied m by itself. The last term has to be a perfect square. So 16 is a perfect square. 4 times 4 is 16. And the middle term has to be the square root of the first term plus the square root of the last term times 2. So that's m times 4 times 2. I think I said plus, but it's times. The square root of the first term times the square root of the last term times 2. M times 4 times 2 gives us 8m. Okay, so I know this is a perfect square trinomial. So if I want to factor it, I can just go ahead and use my shortcut. It's got a plus sign here, so I know it's going to have a plus sign here. And I know it's going to be two binomials, but they're going to look exactly the same. So I'm just going to say that it's one binomial times itself, or squared. Okay, so my first term is the square root of the first term. My second term is the square root of the last term. And I'm done, but just to check it and make sure, the middle term should be first times last times 2. M times 4 is 4m times 2 is 8m. That works. Okay, let's do another one. We're about to do a whole lot more. I just want to talk through it slowly to make sure you understand. Let's say we have, I don't know, t squared minus 18t plus 81. Okay, so now we've got this minus sign. All this tells us is that when we come up with our binomial here, our squared binomial, it's going to have a minus sign here. Okay, so I'm going to have something minus something squared, square root of the first term, square root of the second term, or the last term. Square root of 81 is 9. And the middle term should be first times last times 2. T times negative 9 is negative 9t, times 2 is negative 18t. And that's what I got, right? So square root, and then if I multiply them together times 2, I should get the middle. Okay, hopefully that's making sense. Let's jump back to the worksheet and do some of these. All right, coming down here to our exercises. We won't do all of them, we'll do a few. All right, it says, oops. This part. Determine whether each trinomial is a perfect square trinomial. Write yes or no. If so, factor it. All right, so for this first one, let me get this straight. First term has to be a perfect square. It is. Last term has to be a perfect square. It is. The middle term has to be square root of the first times square root of the last times 2, right? So if I was going to write this out, it has a minus sign here, so I would have, if it's a perfect square trinomial, that means I'm multiplying the same binomial times itself, so I can write it this way. And square root of the first term is x, square root of the last term is 8, and the middle term should be x times this guy times 2. X times negative 8 times 2 is negative 16x. So this is a perfect square trinomial. Okay, let's look at number 2. Perfect square, awesome, so far so good. There's a plus sign here, so if this is a perfect square trinomial, it's going to be in this form. Square root of the first term, square root of the last term. The middle term should be this times 2. M times 5 times 2 is 10m, positive 10m. So this is a perfect square trinomial. I didn't write yes here. I need to write yes here. So far, yes, yes. Now I'm willing to bet this last one probably isn't, but we'll see. Let's see. All right, so if this is a perfect square trinomial, first term has to be perfect square, it is. Last term has to be a perfect square, it is. There's a plus sign here. So if it's a perfect square trinomial, I'm going to get a plus sign in my two binomials. Square root of the first term, that's a p. Square root of the last term is 8. And then the middle term should be p times 8 times 2. P times 8 is 8p, times 2 is 16p. That is not what we have here. 16p. So this is not a perfect square trinomial. For this to be a perfect square trinomial, the middle term has to be the square root of the first times the square root of the last times 2. And it's not. So we're going to write this is not. No. Okay, I hope that's making sense. All right, let's skip around here. I'm going to highlight maybe like 4 that we can do. Let's try this one. Let's try this one. And maybe this one and 11. We'll try that one. All right, number 4. 98x squared minus 200y squared. Well, 98 and 200 don't look like perfect squares to me, right? But can I divide them by anything? I mean, I can divide them both by 2, right? So if I divide them by 2, I'm going to put that 2 out front. Everything left over after I divide. 98x squared divided by 2 is 49x squared. 200y squared divided by 2 is 100y squared. Okay, well, these are both perfect squares, but what are we missing? That middle term. We don't have a middle term. So this is not a perfect square trinomial, right? It's not asking us here if it's a perfect square trinomial. It's just asking us to factor. So this is the difference of squares. How do I factor that? That's when both binomials look the same, but one has a plus sign, one has a minus. So I put my 2 out front, and I know when I factor the difference of squares, I'm going to get 2 binomials. One's going to have a plus sign, one's going to have a minus. The first term in each binomial is the same. It's the square root of this guy, so that's 7x. And the last term in each binomial is the same. It's the square root of the last guy, so that's 10y. So I get 2 times 7x plus 10y times 7x minus 10y. And that's me factoring the difference of squares here. Okay, number 8. This guy. This is a trinomial. I don't have to rewrite this. You know what, let's not. I like to write it with r squared in the beginning, but you can actually still do this without r squared being in the beginning, okay? So the rule is the first term has to be a perfect square. It is. The last term has to be a perfect square. It is. And the middle term has to be the square root, not the square root, I'm sorry, the square root of the first term times the square root of the last term times 2, right? So if I do that here, I'm going to get, should have a minus sign here, and this is squared. So square root of the first term is 13. Square root of the last term is r. And 13 times negative r times 2 is negative 26r. So this is our answer once we factor, okay? You could have rewritten it and wrote r squared minus 26r plus 169, and you would have gotten r minus 13 squared, which still would have been the same thing. Yeah, it would have given us the same answer, because basically if we were going to solve this for r, we would set it equal to 0, right? And so each binomial, there's 2 of these, but they're exactly the same. Each one we'd have to set equal to 0. So if we kept it this way, 13 minus r equals 0, r would have to be 13, right? If we had rearranged everything to be r squared minus 26r plus 169, and we factored that, we would have gotten r minus 13 squared. So in my brain, I'm like, well, r minus 13 is not the same as 13 minus r. But if we set it equal to 0, it is. Because here, for 13 minus r to equal 0, r has to be 13. For r minus 13 to be 0, r has to equal 13, right? So either way, doesn't really matter which way we write it. In this case, it would be the same answer. So you do not have to rearrange this. As long as the first term's a perfect square and the last term's a perfect square, you can write out your binomial and factor it. Okay? Hopefully that makes sense. Number 9, 7x squared minus 9x plus 2. Is the first term a perfect square? No. Is the last term? No. Can I divide these by anything to get them into perfect squares? No. So this is prime. No, actually, not prime. Sorry. We can still multiply first times the last. Sorry, I'm looking for shortcuts. We can multiply first times the last. So we get 14. Are there factors of 14 that add up to negative 9? Negative 2 and negative 7. Yep, that works. So I can rewrite this as 7x squared minus, let's say, 2x minus 7x plus 2. Okay, so I just rewrote the middle term. Instead of minus 9x, I wrote it as minus 2x minus 7x. Now I can group. So I'm going to group these two guys. I'm going to group these two guys. Remember, there's a plus sign in between. Okay, not looking at this anymore. What can I divide both of these by? X. What can I divide both of these by? Nothing, but I do want to change the sign. I want this to be a minus sign to match, and I want this to be positive. So I'm going to divide it by negative 1. Okay, so now I'm going to rewrite this x out front. Everything left over after I divide in parentheses, 7x minus 2. and then this minus 1 out front. Everything left over after I divide in parentheses. My parentheses match. That's what I want. So I'm going to write them in front. This guy and this guy in front. And then I'm going to pull the two leading coefficients together behind x minus 1. Right? This guy and this guy. Okay? So I've got 7x minus 2 times x minus 1. Or you could have written x minus 1 times 7x minus 2. Either way, we factored it, right? It was not a shortcut. This was actually the longest way to factor of any example. But if we recognize a shortcut, we can certainly use it. All right, and then number 11 here. It looks like we have the difference of two perfect squares. We're going to do one more after this too. The difference of two perfect squares. So I know my answer is going to be two binomials. One with a plus, one with a minus. Square root of the first term is 4. Square root of the last term is 5a. And there we go. There's our answer. Let's do one more. I want to do an example of today's thing. Let's do this guy, number 13. Perfect square trinomial. Let's just see if it's a perfect square. It looks like it might be, but let's see. All right, so here, if this is a perfect square trinomial, it's got a minus sign in front. So I know it's going to be something minus something squared. The first term is a perfect square. The square root of 36x squared is 6x. The last term is a perfect square. The square root of 1 is 1. And then the middle term should be the first times the last times 2. 6x times negative 1 is negative 6x. Times 2 is negative 12x. So that works. So this is this is it factored. This is a perfect square trinomial. Perfect square trinomial. Okay, I hope that gives you a good idea with some examples. Stay tuned for video 2. It's coming up next, and let me know if you have questions.